Hello everyone, welcome to this video. In this video, we are going to tackle question 20 of 2025 Beijing Gaokao Math Exam. Before we get started, there are two things that I'd like you to know. First, it is question 20, and it is exactly the second to last problem in this full exam. So judging by its position, you may think it is hard, right? And also, it has 15 points, which is exactly 1/10 of the total scores. It is huge. And the second thing is a clarification. So in this video, you may see a symbol ln of x. Now this represents the natural log, which is log base e of x. Okay, so this term, I will read it as the natural log of 1 plus x. So after these two clarifications, we can get started, but just before we dive in, if you want to experience the difficulty of Chinese Gaokao in person, you want to challenge yourself, then pause the video and try to solve these three parts each by each. In this video and next two following videos, I will give solution to every part of this question step by step. Okay, so now we can really get started, and first we should focus on the problem statement to find or extract the key informations of this problem. Now we're giving a function f of x with the domain being -1 to plus infinity. It is an open interval. F of 0 is 0, and f prime of x is equal to the natural log of 1 plus x over 1 plus x. The straight line L sub 1 is the tangent to the curve y is equal to f of x at the point A, with the coordinates being a, f of a, where a is not equal to 0. Okay, after reading this statement, some of you may be confused. Where is the information of the original function f of x? Or what is the form of the function f of x? Yes, you may think without calculus knowledge, we cannot find the original form of f of x, but don't panic, okay? We just have to take full use of what we already have while the conditions are given. So let's focus on the problems. And the part 1, find the maximum value of f prime of x. Okay, so as you can see, this problem treats f prime of x as a very brand new function. Now we can denote it as g of x. So now let's denote g of x is equal to f of x, which is equal to the natural log of 1 plus x over 1 plus x. Okay? So here comes a very crucial problem. How to find a maximum value of the function. Okay? Generally, for continuous and well-defined function, there are 4 steps. First, we should find out the domain, right? Because the domain of the function directly influences the range. And step number 2, we have to find critical points. So what does a critical point means? It is where the first order derivative of this function equals to 0. Okay, so in this specific problem, it is where g prime equals to 0. Okay, so step number 3, after finding the critical point, we can determine how the function goes on the left side of the critical point or on the right side of the critical point. It is described as the monotonicity. We can describe the function whether it's increasing or decreasing. Okay? And the final step, which is conclusion. We can give a conclusion to what exactly the value is. Okay, so these 4 steps from the general process of finding the maximum value, the minimum value, or boundary value of a function. So with these 4 steps, let's fill them out to really solve this problem. First, what is the domain of g of x? Notice that the term 1 plus x appears on the denominator, so should not be equal to 0, right? But please be noted that the term 1 plus x also appears on the argument of the logarithm, so 1 plus x should be strictly greater than 0. Okay, so combining these two inequalities, we can find x is not equal to minus 1 and x is strictly larger than minus 1, which comes down to the true domain of the function g of x, which is x belongs to the open interval from minus 1 to plus infinity, which is exactly the same as the function f of x, its domain, right? Okay, now let's come to the second part, how to find the critical points. As we read out here, an important step to find the critical point is to take the first order derivative of the function. Since this function is a quotient, right? It is a quotient. We have to apply the quotient rule when we find the derivatives. So what is the quotient rule? A quotient rule means if the function g of x has the form u of x over v of x, where v of x is not equal to 0, then g prime of x is equal to what? Did you remember? Yes. For short, I write here v squared to represent the square of v of x, okay? And the numerator is u prime times v minus v prime times u. Okay? So in this case, we can regard the numerator, the natural log of 1 plus x as u of x, and regard the denominator 1 plus x as v of x. But please pay attention. This numerator is actually a composite function, okay? It is equal to u of w of x, where w of x is equal to 1 plus x and u of x equal to the natural log of x, right? So for composite function, we have this formula. If we want to take the derivatives of the composite function, it is equal to u prime of w of x times w prime of x. It is called the chain rule. Okay, so apply this to this specific form. The derivative of the natural log of 1 plus x is equal to what? That's right, 1 over 1 plus x times 1, right? Because the derivative of 1 plus x is just 1, and it's equal to 1 over 1 plus x. Okay, so with this in our mind, we can now fill out the expression of g prime of x. Let's substitute them into the specific form. It is, where is u prime x? Yeah, it's 1 over 1 plus x, and v times 1 plus x minus, what is v prime? Yes, it is 1. And what is u? It's the natural log of 1 plus x. And the denominator is v squared. It is 1 plus x squared. Okay? And it just equals to 1 plus x squared, and the numerator is 1 minus the natural log of 1 plus x. Okay, now, here we can find that the denominator is always strictly positive, right? And it can never equal to 0. So we can just focus on the numerator. How to find the critical points? Did you remember? Yes, we can set g prime of x equal to 0, right? Which is equivalent to the natural log of 1 plus x is equal to 1, right? And to solve this, we have to know this implies or is equivalent to 1 plus x is equal to e. And e is the natural number, right? And this implies x is equal to e minus 1, with the approximate value being 1.718, which is strictly larger than minus 1. Therefore, we find an interior critical point of g of x. That's what we want. Okay? So step number 3, we can determine the monotonicity of g of x. So if we let g prime of x, if we want the g of x be increasing, we have to let g of prime of x what? Yes, it's larger than 0. Okay? And because the natural log of 1 plus x is its sign is minus, so this inequality is equivalent to what? Yes, it's equivalent to x is strictly less than e minus 1. But combining this and the domain, we have to conclude that g of x is what? Yeah, increasing on the interval, on the open interval minus 1 to e minus 1, right? And on contrast, when is g prime of x is positive, it is equivalent to x is strictly larger than e minus 1, which means g of x is decreasing on the open interval e minus 1 to plus infinity. Okay, so this function is increasing on the interval minus 1 to e minus 1 and decreasing on the open interval from e minus 1 to plus infinity. Therefore, we can find the maximum value because e minus 1 is just the maximum value point, right? So the conclusion is g of x, its maximum value is equal to what? That's right, it's just g of e minus 1. And substitute e minus 1 into the original form, we have it is equal to the natural log of 1 plus e minus 1 over 1 plus e minus 1. Okay? Comes down to the natural log of e over e. And it is exactly 1 over e. So this comes down to the solution to the first part of this question. So thank you for watching this video, and if you have anywhere that you do not understand or you have any other question that you want me to solve to help, please feel free to leave a comment below and I will check out ASAP. Thank you again for watching this video. Hope you have a good day. I will see you in the next video.